Have you ever pondered about the mysteries that the far side of the moon holds? This celestial body, our closest neighbor in the vast expanse of space, has captivated our curiosity for centuries. Its near side, with its familiar faces and contours, is well known to us. But the far side, often mistakenly dubbed the dark side, remains shrouded in mystery and intrigue. Despite leaps and bounds in space exploration, this hidden hemisphere continues to harbor riddles that challenge our understanding of lunar and cosmic phenomena. In our journey today, we'll delve into 5 of the most compelling enigmas of the moon's far side. From the striking difference in terrain, to the origin of the colossal South Pole-Aitken Basin, from the puzzling magnetic anomalies to the moon's thermal inconsistency, and finally, the potential for extraterrestrial life and water ice. Join us as we journey to the moon's far side to unravel these enigmas. First, we delve into the stark contrast between the near and far sides of the moon. The near side, the one that we see from Earth, is characterized by dark, flat areas known as maria. These basaltic plains were formed by ancient volcanic activity, giving the near side its distinctive face-like appearance. But switch to the far side, and the terrain changes dramatically. It's a rugged, heavily cratered landscape with a thicker crust and almost no maria. It's like looking at 2 completely different celestial bodies. So why is there such a difference between the 2 sides? Over the years, scientists have proposed various theories to explain this striking asymmetry. One theory suggests that the moon was once part of a double-planet system with Earth. In this twin system, gravitational interactions could have led to the differences in crustal thickness and surface features we see today. Another intriguing theory posits that a second moon, smaller than the primary one, impacted the primary moon on its far side. This big splat could have resulted in the rugged highland terrain we see today. But why does this matter? Well, understanding why the 2 sides of the moon are so different could provide valuable clues about our moon's formation and geological history. It could also shed light on the processes that shape other moons and planets in our solar system. It's worth noting that these theories are still being tested and refined. Future lunar missions and new technologies may provide the data needed to support or challenge these ideas. For now, the stark contrast in terrain between the near and far sides of the moon remains a captivating enigma, a testament to the mysteries that our closest celestial neighbor still holds. This terrain difference challenges our understanding of the moon's formation and geological history. And with every new discovery, we edge closer to unraveling the enigmatic far side of the moon. Let's turn our attention to one of the largest and oldest impact craters in the solar system. The South Pole-Aitken Basin, a remarkable feature on the far side of the moon, is a marvel to astronomers and scientists alike. Imagine a colossal crater with a diameter of roughly 2,500 kilometers, plunging deep into the lunar crust to a depth of about 8 kilometers. It's a sight to behold, even if only through the lens of a telescope or the images sent back by lunar missions. The South Pole-Aitken Basin is not just a visual spectacle, but it's also a window into the moon's past and possibly into the history of our solar system. What makes this basin particularly significant is that it exposes the deep layers of the lunar crust. This opens up a unique opportunity for scientists to study the moon's internal structure and composition. The layers revealed by this impact crater are like pages in a book, each holding a story about the moon's geological history waiting to be deciphered. However, the origin of the South Pole-Aitken Basin is still shrouded in mystery. How did such a vast and deep impact crater form? What celestial event could have caused such a dramatic indentation on the lunar surface? Theories abound, from a colossal asteroid collision to an internal geological upheaval. Yet, each theory seems to raise more questions than it answers, leaving us in a state of tantalizing uncertainty about the basin's true origins. The impact of the event that created the South Pole-Aitken Basin was undoubtedly momentous. It's likely that such a significant event would have left its mark not only on the moon, but also on the entire solar system. Therefore, understanding this basin isn't just about learning the moon's history, it could also shed light on the early solar system and the cosmic processes that have shaped our celestial neighborhood. Unraveling the secrets of this basin could provide valuable insights into our early solar system. Its story may be etched in the lunar crust, waiting for the day when we finally decipher its ancient tale. Have you ever heard of the moon's mysterious magnetic fields? Well, they exist, and we're not talking about a global magnetic field like Earth's. Instead, we're referring to localized magnetic fields or magnetic anomalies that are particularly prevalent on the far side of the moon. These magnetic spots are a source of fascination and confusion among scientists and space enthusiasts alike. The intrigue stems from the fact that, unlike Earth, the moon doesn't have a dynamo at its core, generating a global magnetic field. So the presence of these localized magnetic fields is a puzzle that has yet to be fully solved. These magnetic anomalies are not just random, they have a structure to them. They are concentrated in certain areas, hinting at an underlying process or phenomenon that we have yet to fully understand. Several theories have been proposed to explain these lunar magnetic anomalies. One theory suggests that they are remnants of an ancient lunar magnetic field. This idea posits that billions of years ago, the moon had a molten core that, like Earth's, generated a global magnetic field. Over time, as the moon's core cooled and solidified, the global field disappeared, but pockets of magnetism were left behind, frozen into the lunar rocks. Another theory proposes that these magnetic spots are the result of asteroid impacts. This idea suggests that when asteroids, some of which could be magnetized, struck the moon, they brought with them magnetized material. This material then spread out upon impact, creating the magnetic anomalies we see today. Regardless of which theory holds true, these magnetic spots challenge our understanding of lunar and cosmic phenomena. They are yet another piece of the lunar puzzle that we are striving to solve, another enigma of our nearest celestial neighbor. As we continue to explore and study the moon, we inch closer to unraveling the secrets of these magnetic anomalies, bringing us one step closer to understanding the moon's past and its relationship with our planet. These magnetic spots challenge our understanding of lunar and cosmic phenomena. Now let's explore a puzzling thermal mystery. The far side of the moon, our silent neighbor, holds secrets we're still striving to uncover. One of the most intriguing is the thermal inconsistency this side of the moon presents. We have data from various lunar missions that show there are variations in the heat flow from the moon's interior. Interestingly, the far side seems to have a different thermal profile than the near side. This thermal distinction is not just a curious detail, it's a challenge to our understanding of the moon's thermal evolution and internal dynamics. It raises questions about what could cause such a difference. Could it be due to varying compositions within the lunar crust? Or perhaps it's a result of distinct geological activities that have occurred over the moon's lifetime? Whatever the cause, investigating these thermal anomalies could open up new avenues of understanding. It could reveal uncharted aspects of the moon's geological activity, shedding light on the processes that have shaped it over billions of years. This, in turn, can enrich our knowledge of the moon's thermal history, helping us piece together the story of our closest celestial neighbor. This thermal puzzle adds another layer of complexity to our understanding of the moon. As we continue to probe these mysteries, who knows what other fascinating secrets the far side of the moon might reveal? Finally, could the far side of the moon harbor life and water ice? This question may sound like science fiction, but recent discoveries have brought it into the realm of science fact. The moon, long considered a barren and lifeless celestial body, has surprised us with the discovery of water ice. These ice deposits are found in permanently shadowed craters, particularly near the lunar poles. These areas are in perpetual darkness, creating conditions cold enough for water ice to remain stable. The significance of this discovery cannot be overstated. Water is a fundamental ingredient for life as we know it. While the conditions on the moon are harsh, the presence of water ice opens up the possibility, however slight, for the existence of life. This could take the form of extremophiles, organisms that thrive in extreme conditions. Additionally, this water ice could serve as a crucial resource for future lunar missions. It could provide drinking water for astronauts, be used to cultivate crops, and could even be broken down into hydrogen and oxygen, providing breathable air and fuel for rockets. The search for water ice and the life it could potentially support is an ongoing area of lunar research. Scientists continue to explore and study these shadowed craters using a combination of satellite data and planned future lunar missions. This discovery could revolutionize our understanding of the moon and its potential for supporting life. In our journey to the moon's far side, we've seen that it's a realm of enigmas and intrigue. We've delved into the striking difference in terrain, a stark contrast that continues to puzzle scientists about the moon's formation and geological history. We've explored the colossal South Pole-Aitken Basin, an ancient impact crater that could provide insights into the early solar system. We've pondered the mystery of the lunar magnetic anomalies, localized magnetic fields that defy the moon's lack of a global magnetosphere. We've considered the puzzle of the moon's thermal inconsistency, a perplexing difference that challenges our understanding of the moon's thermal evolution. We've contemplated the potential for extraterrestrial life and water ice, a discovery that could fuel future lunar missions and research. While we've made strides in lunar exploration, the moon's far side continues to challenge our understanding and inspire our curiosity. Thank you for joining us on this lunar journey. We've traveled through the mysteries and marvels of the moon's far side, and we hope it sparked your curiosity just as it continues to ignite ours. We'd love to hear your thoughts on these lunar enigmas. Are there any that particularly intrigue you? Any theories or insights you'd like to share? Please leave a comment below. And if you've enjoyed this exploration, consider subscribing to our channel. We have many more journeys through the cosmos planned, and we'd be thrilled to have you along for the ride. As we continue to delve into the unknown, remember this: stay curious and keep exploring.